Prolog and 64-bit machines. SWI Prolog supports for 64-bit with 64-bit machines where we refer to CPUs where memory addresses are 64-bit wide. Machines started with version 2.8 or DEC Alpha CPUs running Linux. Initially, 64-bit hardware was developed to deal with addressing demands of large databases running primarily on expensive server hardware. Recently, we see CPUs that support 64-bit addressing become commonplace, even in low-budget desktop hardware. Most today's 64-bit platforms are capable of running both 32-bit and 64-bit applications. This asks for some clarification on the advantages and drawbacks of 64-bit addressing for Prolog. Comparing 32 and 64-bit Prolog. Most of Prolog memory usage consists of pointers. This indicates the primary drawback. Prolog memory usage almost doubles when using the 64-bit addressing model. Using more memory means copying more data between CPU and memory, slowing down the system. What then are the advantages? First of all, SWI Prolog's addressing of the Prolog stack does not cover the whole address space due to the use of type tag bits and garbage collection flags. On 32-bit hardware, the stacks are limited to 128 MB each. This tends to be too low for demanding applications on modern hardware. On 64-bit hardware, the limit is 2 into 32 times higher, exceeding the addressing capabilities of today's CPUs and operating systems. This implies Prolog can be started with stack sizes that use the full capabilities of your hardware. Multi-thread applications profit much more. SWI Prolog threads claim the full stack size limit in virtual address space, and each thread comes with its own set of stacks. This approach quickly exhausts virtual memory on 32-bit system but poses no problem when using 64-bit artificial intelligence and Prolog. Artificial intelligence techniques are used in the development of intelligent computer systems that can emulate a human expert in a specific domain. You can apply these systems in domains where human expertise is required to solve problems such as detecting faults in supercomputers, interpretation of images from space, and diagnosing pulmonary diseases. Expert systems are computer programs that store information from human domain experts. This information is stored in a special database referred to as knowledge base. Knowledge bases are used to solve problems in diverse application domains such as space science, medical science, geology, and robotics. Prolog provides rapid prototyping and is ideal for developing artificial intelligence systems because it dynamically generates code, automatically manages memory, backtracking, and recursion. Automatic memory management. Artificial intelligence systems use data structures that require frequent allocation and deallocation of memory. As a result, these systems require dynamic search techniques that can allocate and deallocate memory frequently. There are three bottlenecks that can occur in memory management. The first one is premature free. Occurs if the program is coded to handle the allocation and deallocation of memory manually. As a result, a block of memory may be freed after being used by one part of a program but may be in use by another part of the program. The second one is memory leak. Occurs if a memory block is allocated but not freed. This may result in the program running out of memory resources. The third one is the double free. Occurs when an attempt is made to free a memory block that has already been freed. The automatic memory management feature of Prolog dynamically allocates and deallocates memory to provide premature frees, memory leaks, and double frees. Prolog file IOs. The following predicates manipulate files. C. The file becomes the current input stream. File may be a stream previously opened by C/1 or a file name. If it is a file name, the following action is taken. If there is a stream opened by C/1 associated with the same file already, then it becomes the current input stream. Otherwise, the file is opened for input and made the current input stream. C. File name is are unified with the name of the current input file. If it was opened by c/run with the current input stream, if it is not user input, otherwise with the user. Scene closes the current input stream and reset it to user input. Tail. The file becomes the current input stream. File may be a stream previously opened by tail/run or a file name. If it is a file name, the following action is taken. If there is a stream opened by tail/run associated with the same file already, then it becomes the current output stream. Otherwise, the file is opened for the output and made the current output stream. Telling. File name is unified with the name of the current output file. If it was opened by tail/run with the current output stream, if it is not user output, otherwise with user. Door closes the current output stream and resets it to user output. Here is an example of common form of file processing. Nearly all sensible users of repeat/0 follow the above pattern. Note the use of a cut to terminate the loop. With that, we conclude our presentation. Thank you for your cooperation.